Okay, so we're going to start talking about trig. And what we know of trig so far has been like sine, cosine, tangent. And we're going to get there. But first, we have to learn some specifics of angles. So what we're going to do now is all of the angles we draw are now going to be on graphs. And I know that makes you super excited. So everything we're going to draw is going to have a graph. So as per usual, this is our x-axis and this is our y-axis, right? And I don't know if you've talked about this lately in math, but each area of the graph is a different quadrant. Did you guys know that? So they're numbered like this. This is quadrant 1, and we use Roman numerals. This is quadrant 2, and a lot of times we write Q because the word quadrant's far too long for us to write. And this is quadrant 3, and then this is quadrant 4, and the Roman numeral for 4 is IV, because V is 5. And since the 1 is on the left, it's 1 less than 5, which is 4. Okay, so quadrant 1, 2, 3, 4, 5, 4. All right, now when we draw angles from here on out, we're going to draw them in a certain way, and this is called standard position. Okay, so all of our angles are going to be drawn in standard position, and every single one of them is going to start right here on the positive side of the x-axis. And remember, this is just an arm of an angle, so it can go on forever, so it usually gets an arrow. And our angle is always going to travel from here and go up in this direction. Okay, angles travel through quadrant 1, then quadrant 2, then quadrant 3, and then quadrant 4. So they always move in this motion. Well, not always, but for the most part. So the other arm of the angle, so you can kind of envision this, as the second arm, and the other arm is going to look, something like this. So the other arm can be, anywhere it wants to be. So it can be here, or, it could be in any of the quadrants. But then we label it with a little arc, and we call the angle theta. Do you remember this? Theta. Okay? Now, these pieces of the angle have names. So this is what we call initial arm. This is the initial arm, and it's always on the x-axis. This guy is the terminal arm, and the terminal arm can move anywhere it wants to. Okay, so recap. Our angles have crash landed on graphs with x-axes and y-axes, so x, y. The graph is divided into 4 parts, Q1, Q2, Q3, Q4. The way I remember Q1 is right here is because Q1 is what we call positive, right? Like if you were to plot a point there, your x would be positive, right? Like these are all the positive x's, and these are all the positive y's, so anything in here is positive. And then Q2 is negative, positive, right? Because your x's are negative over there. And in Q3, you're negative, negative, which is kind of cool. And in Q4, you're positive, negative, right? In terms of what type of x and y. So like if we plotted a point here, it would have a positive x and a negative y. So that's why we say positive, negative. Okay, so let's take this a step further. So knowing everything we just looked at, this is what things can do. So here's our graph. And let's say we want to draw an angle that is 120 degrees. So if I want to draw an angle that's 120 degrees, I have to put my initial arm right here, right? This is where 0 degrees is. And if I want to go to 120 degrees, well, I know that this is 90, right? Straight up and down. And so this is 180 over here, correct? Right? If I keep going with that, and this is 180, then what is this going to be, right? This is 90 from here to here. What's 180 plus another 90? That's going to be 270. And then that makes this piece also 360, right? If I was going to draw like a full circle, 360 degrees, right? Okay, but back to my 120. I need a 120 degree angle. So 120 is bigger than 90, but not as big as 180. So the arm of this angle is going to be like right here, right? And I could get out a protractor and do this the right way. So that means that I've got a theta right here of 120, right? And my arm is in Q2. Everybody cool with that? Okay, let's try another one. What if I asked you to draw, let's say, an angle of 200? Okay, 200. So I'm going to draw my graph again. And I know that my initial arm has to be here at 0. And then my terminal arm, remember again, here's 90, here's 180. So that means 200 is going to be just past 180, right? So probably over here. So look at this angle. This angle goes all the way over here. And that's all one angle. That's my theta. It's 200. It's huge. Now, here's the kicker. We're going to add in another really important angle. So these angles are both in standard position. And as you can see, this angle right here, this 120, it looks like a normal angle, right? It's obtuse, but it's fine. This angle is a little bit wild. It's going almost like backwards, but it's okay. It's perfectly legal. There's something we're going to start looking at that's called the reference angle, and I'm going to zoom in on this one right now. So the x-axis is going to be an important player in this game. The x-axis is going to serve as a particular point that's going to show us reference angles. So the reference angle is the angle created between, this is the reference angle, and it's called theta r, and it gets a little r next to the theta. Now, the reference angle is between the terminal arm and the nearest x-axis, okay? Not the y-axis, has to be the x-axis. So if that's the case, then you can see it goes from here to here. The question is, how big is this? Well, if this terminal arm's at 120 and the x-axis is at 180, what's the reference angle here? The difference between 120 and 180 is 60, okay? 60. So we have a theta r of 120, okay? Theta r of 60, and theta is 120. All right, come back over to this guy. Where is our reference angle? Let me get rid of this. Where is our reference angle? Here. Remember, we said reference angles go between the nearest x-axis and the nearest terminal arm. So that means my reference angle is right here. This is my theta r. So this is 200. What's the difference between 200 and 180? The difference is 20. So I have a 20-degree reference angle. All right? You with me so far? Okay, and this is quadrant 3 that we just looked at. So what if we do the same thing in quadrant 4? So here's my graph, and I'm going to ask to draw a 310 degree angle. Okay, so I'm going to put my initial arm here. I'm going to cruise to 310, so I'm going to go past 90. I'm going to go past 180. I'm going to go past 270. This is 360 if I go all the way up here, so I don't want to go quite that far, but I want to go close, so probably here. Now remember, you have to travel in that certain direction, so you have to travel from Q1 to Q2 to Q3 to Q4. So this is all theta. My theta is 310. It had to go in that direction. That means the reference angle is this tiny little piece of the puzzle. Okay, that's my reference angle. And what's the difference between 310 and 360? It's 50. So my reference angle is 50 degrees. Okay? Now, let's look at that one more time. Let's look at one more angle. Okay, here's my graph. What if I want you to draw an angle that is 45 degrees? Well, put your initial arm out again. This time your terminal arm's gonna go right here, right? Halfway in between 0 and 90. So this is my theta, 45. But remember, we said that your theta r, your reference angle, has to go to the nearest x-axis. Well, the nearest x-axis is right there, right? It's here too. So that means theta r is also 45 degrees, okay? So in quadrant 1, you have this like weird anomaly that your theta and your theta r are the same thing, okay? So it's pretty straightforward. Your reference angle always goes to the nearest x-axis. Now, let's just write this out one more time. Full recap for screenshot. You have graphs now, okay? And in that graph, you have an x and y axis. Your y-axis going straight up and down is 90 degrees. Your x-axis on the left side is 180. Downward on your y-axis is 270. And right here is 0 and 360, right? That all makes sense. This is Q1. Then you have Q2. Then you have Q3. Then you have Q4. Angles are drawn in standard position, which looks like this. Okay, you have a terminal arm and an initial arm. Your theta goes from the initial to terminal. So theta is from initial to terminal. Okay, your theta r is your reference angle. And goes from your terminal arm to the x-axis. Cannot go to the y-axis. Okay, so screenshot that. That's everything in a nutshell. Now, one more thing. I'm going to give you some formulas. You can use logic better than these formulas, if I had to guess, but I'm going to throw it out there anyway. Okay, if you have a reference angle in quadrant 1, your reference angle is the same as your theta. Okay, they're the same. If you're in quadrant 2, your reference angle is 180 minus your angle, right? Because doesn't that make sense? Like if you had a 120-degree angle, you would say 180 minus 120 is 60, okay? If you're in quadrant 3, your reference angle is going to be 180 plus theta, right? Now, you don't need to memorize these. You can look at your angle and figure out how far it is from the x-axis, unless you need this these formulas. I mean, they do exist. We just, don't necessarily use this stuff all the time. Sometimes logic and reasoning is just a little bit easier. Okay, here in quadrant 4, your reference angle is going to be what? Can you think of it? Your reference angle is going to be 360 minus theta, all right? Because if you had like 310 here, we would have said 360 minus 310 is 50. So that's how that works. So you can screenshot those formulas. Okay, good luck.